Hi guys. My name is Ramapriyan Srivatsan, and the PD stands for another two really long names, but you can just call me Rama. Rama, yeah, it's just very simple. And yeah, I study CS and Maths, DDP, and I'm year two. Amadeus also is year two. So the thing is, we ourselves we're also learning every day. So we're not really you wouldn't. I mean, we're not the finished article by any means, by no stretch of the imagination. But what we are is, or what we hope to be is excellent communicators of the basics of machine learning at this point. So we the half the job of a teacher is the domain knowledge, and the other half of the job is getting the message across. So we hope to get the message across to you guys. That's the main aim. um, and just to kind of give you an overview of what the upcoming training is going to be like, we're going to go through about 6 or 7 weeks of really topics of content, and 6 or 7 sessions basically, and we're going to discuss a range of basic sort of machine learning techniques, models, etc., etc. And yeah, there'll be 2 projects through the semester, which you guys will have to. The projects aren't really massive or anything, so don't stress. Just do your research and then ensure that you come out of it with something that you've learned. Right? That's what we want. We want you guys to learn. That's basically the point. Um, about myself, I feel like I've talked a lot about machine learning in the department, so I'll just talk maybe a bit about myself. I myself, in year one, I was really, how do you say this, in the most Singaporean way possible. I was really blur myself. And yeah, I just took an effort, made an effort, took an interest in this and that. And some way, somehow I'm here. So yeah, if you guys do the same thing and, just go a little bit, go a little bit above the minimum and just put in some effort, you guys can get into this domain as well. Besides that, I don't think you guys want to know what my interests are and all of that. I think you guys will forget that after I just say it. So there's no point going into that. So now I'll just pass it to Amadeus. Yeah.
All right, nice. And yeah, so I think the directors and Rama pretty much said everything already. Yeah, so first of all, my name is Amadeus, second year CS student. And yeah, so machine learning, our job here as the training heads, training leads are, as Rama mentioned, to communicate the ideas behind machine learning and the domain knowledge of that is fintech to you all. So we are not going to pass on everything, like all the knowledge there is to know. That's not gonna happen, because I mean, not like we know everything also. But hopefully what we can pass on is the interest, and also perhaps some of the things to avoid, and some of the mistakes that can be avoided. Yeah, and some of the perhaps first things to try when encountering problems in a fintech project. So yeah, these are a big summary of the takeaways from this training week.
Can I? Yeah. Sorry. Yeah. Continue.
Oh, okay.
Continue,
Yeah, I'm done.
So I mean, we've covered who we are and all that. I just want to lay out some sort of framework for what your guys like, your how you guys can interact with us throughout these presentations, right? So if you guys have a question or something, please unmute. Like we would really love it if you just unmuted, interrupted us rudely. I don't care. Just do it, and then just ask us a question. Nothing makes us happier, especially on a Zoom or a Teams thing, right? It's great to have people asking you questions, right? The other thing is, if someone wants a break or something and thinks like 2-minute break, 5-minute break or something, or you think it's getting a bit much, right? Just message us like on the chat, or just say it, and we'll be like, okay, cool, because you guys know best when something is getting tedious, right? So it would be great if you guys can interact with us and make sure that your experience is bettered by giving us in real time feedback as well. Apart from that, yeah, we really appreciate, and we really insist. Okay, insist may not be the best word, but yeah, whatever the word is that is just short of insist, but isn't so mandatorily imposing. We'd like you guys to show your video during the session, yeah, because that forces you guys to pay attention. Number one, that also keeps us engaged, fully. So that's what we'd like to see. Yeah. Anyways, we can move on.
All right, nice. And yeah, so I think Rama mentioned this. It's basically about 6 to 7 weeks of stuff going on. Today is, well, introduction. Yeah, so today's session will be quite chill and we won't be taking up the full 2 hours. I don't think so, at least. And week 5, which is next week, will be the intro to machine learning and linear regression. Week 6 is time series, which is where the first project will be released also.
Let me just interject. One thing, right? We are thinking of having our week 7 class. We were thinking of having it during recess week itself. The reason being, we want to get you guys doing the projects, all of that, much earlier, so that you guys don't face the backlog or the stress later in the semester. So yeah, recess week is probably going to be. We're probably going to move the last 3 classes up a week. Yeah.
Yeah. Because after week 9 you have your finals and stuff also, so we do not quite want to interrupt that, hence this particular scheduling. And yeah, so that's training plan. Project grading, okay, this doesn't quite matter much for now, but apart from these being the rubrics, right, I think this also framed the entire training wing process, which is that performance of your models, whatever model you decide to use, is not the most important thing. The important thing is to actually try out different techniques so that you know the pros and cons of the different things, and also not to just take some data and then throw into this model and treat the whole model as a black box, like throw it into a model and then not care about it at all. So yeah, this is not what we are looking for. What we look out for is how you think about a particular problem, so angle of approach, and this how you think of the problem. It can be commented in either a README document, in a separate document basically, or basically just as minor comments here and there. Yeah, basically what we want to know is your thought process and not just the final outcome. And another thing is the use of GitHub. Okay, we'll cover this some other time, but basically it's a project management. You can use GitHub to manage your code and all the other related files. So GitHub you can use it basically for tidiness, to tidy up your code and stuff. All right, I think we can begin. So, right.
Okay, guys. Sorry.
Yep.
Youngler now take a leave first. Anyways, the rest of you guys, all the best. Have fun. Yeah. Don't think of this as a module kind of thing. It's just it's going to be a fun session, I guess. Yeah. Okay. See you guys. Bye.
Yeah. Thanks.
Amadeus. I'll be taking my leave as well.
Right? All right. Sure.
Yeah.
Okay.
So I'll see you guys, all of you next week. Yeah. Looking forward to it.
Yeah. Thanks. Basically, me and Rama will be sort of taking turns with each other. Yeah. So okay, I think we can continue. So you probably have heard of this term called data science before. Yeah. So machine learning is sort of a subset of data science, right? Data science is basically how you answer certain questions involving reality using data. So these kind of the questions that are asked could be something as generic as how much time do you study to get an A, or it could be something quite fintech related. So maybe what is Tesla's stock price tomorrow, right? And a usual pipeline of a data science project is as shown in the diagram. So as the name suggests, you must have some form of data as a foundation of your thought process. But at the same time, you also need to formulate your questions and hypotheses beforehand, right? So you have a question that you want to find an answer in mind, and then the idea here is to use your data to generate meaningful features. So you can think of features as basically meaningful information that can be derived from the data, right? And then normally, if you're not talking about machine learning, then you would use these features to come up with the answers yourself. But because we are in the machine learning division, instead of us here, the model is a computer. So you pass in the information into the computer, and the computer will generate the answers, right? So this is an entire data science project. And as mentioned before, we don't want machine learning to be sort of just tossing stuff into model, right? And that is why the diagram doesn't look like this. It's not data straight away go into computer and then computer spit out answer. Why can't we just pass data straight into model? The reason why is because basically your data contains too many information. It can give you even the wrong impression sometimes, or it may not even be in a form that is understandable to the computer, right? So there's an example down there. Basically, your data can contain things like dates, right? So 31 January 2000, but the computer doesn't quite understand how to interpret these dates. You see, so they don't know things like what are years, what are months, what are days. You know that January only can go up to 31 days, but February is 28 days and not 31. These kind of things. So there's a need for you to change how this kind of information is displayed or is structured, so that the computer can understand. Yeah, and it's not just dates. Even something like, for example, an image, right? A picture of a cat. I mean, humans can see an image quite easily and understand that that's a cat. But to a computer, an image is just a bunch of zeros and ones. So it doesn't quite know that that's a cat. Yeah. So that's that. And then another problem, apart from the fact that computers don't understand, is that the data can give wrong impressions. So this is a particular example where the data doesn't tell the full story, right? So suppose this is the data that you have. So it's just a bunch of points drawn in this diagram. So the x-axis is how often you exercise, and the y-axis is your cholesterol level, right? So the higher you are up in the y-axis, that just means that you have more cholesterol, and the more to the right you go, that means you exercise more, right? So you see the diagram in the left and the diagram in the right, right? They are exactly the same data point. There's no data points that are absent in the left but is present in the right. They are literally exactly the same. The only difference is how you choose to interpret this data. So maybe I'll start from the right one. Now, if you interpret the data in the right one by saying that, okay, there seems to be a straight line going through that cluster of data, going through that oval there, it seems to suggest that the more you exercise, the higher your cholesterol level is, which, well, if you purely use the data, it seems like that's counterintuitive, right? Like why is exercising more resulting in more cholesterol? Oh, by the way, cholesterol is not a good thing. It's linked to like heart disease and stuff. So this data on the right would suggest that the more you exercise, the more likely that you'll have heart disease. And this is the outcome, the conclusion that you will get if you simply throw your data into the computer and not control for certain aspects. But if you consider the left diagram, you see there's a downward sloping line, right? So there are different clusters. There's like a total of 5 clusters, I think. Yes. So the clusters are actually what you would observe once you control for age. So the top cluster at the top right corner is for people who are age 50, and then age 40, 30, 20, 10. So once you consider the fact that these ages exist, then now the data makes much more sense, right? So in fact, once you control for the age, exercising actually means you have lower cholesterol. And this sort of fits our understanding of biology a bit better. Yeah, so this is what we mean by you need to have an idea of the question and form hypothesis first, so that if the data suddenly give you an answer that doesn't quite match your hypothesis, you can question whether the data is in fact correct or not, if that makes sense. Yeah. So this is another example where looking at the data alone doesn't quite help. But in the previous case, what happens is that once you control for the age, things make sense. But in this case study 2, controlling for stuff will actually make matter worse. So if you separate it into like male and female, right, you end up with a less correct conclusion than if you combine them together. So yeah, so the question here is, does drinking soda before exam help you to get an A? So intuitively, your hypothesis will be that no lah, right? You don't quite expect drinking a soda before exam to suddenly boost your score and get it into an A. And in fact, if you look purely at the data, you'll get that conclusion of 76.9, 76.9. So yeah, no change in percentage of A. But if you split it into male and female, right, there's this illusion that it looks like drinking soda will actually help increase your chance, you see. Because if you're a male and you don't drink a soda, your probability of getting an A is 63. But if you drink soda, it becomes 66. And in fact, the same is true for the female. So not drinking soda is 83 and drinking soda is 86, right? So in this case, once you control for the different aspects, you end up getting a strange conclusion that doesn't quite match your understanding of reality. So the point of these two examples is that you need to inject some form of your own personal knowledge into the model or into the data. So you can add or drop the information in your table as necessary, such that the conclusion makes sense lah. Yeah. Right. I think that's all. Yeah, so for today, we'll basically look into this form of data called tabular data. And in tabular data, your data is basically present inside a table, right? So it looks like an Excel sheet, basically, yeah. The things that you might need to do for when you receive a tabular data is to deal with missing data first and foremost, because the data that you receive, for example, from companies and stuff, right, most of the time there will be entries where it could be someone forget to fill in the table and then you end up with an empty cell, or it's just it doesn't quite have an answer, like that particular entry have no specific answer to it, and that's why it's missing. Yeah, so you need to figure out how to handle this kind of missing data. Do you want to throw it away, or do you want to sort of just fill a dummy information into the empty cell? Yeah. Another thing is to use your prior knowledge, to use context and whatever hypothesis that you have formed to decide whether you need to drop some columns. So you want to throw away certain information, or you want to combine information across columns to come up with a better, more useful information. So this part here is what we mean by making features, right? So if you remember from the graph previously, what we said was you have raw data and then you have questions and hypotheses, and you combine these two to get features. Yeah, so this is exactly what you're doing. You combine information in such a way that you get a more useful version of it. And then lastly is to modify the representation of the data such that the computers can understand. So instead of dates, maybe you want to convert it into just numbers, so that computers know that 2 comes after 1, right? So that might be a useful way to tell computers that February comes after January. You can convert January into 1 and then convert February into 2, for example. Yeah. And how do we do all these three? We use these libraries called Pandas and NumPy, right, in a programming language called Python. So you all did the questionnaire. So one of the questions, I believe, requires the use of Python. This is because in machine learning, Python is quite frequently used because of its relative simplicity. And yes, which brings us to Pandas. Yeah, so this is a compulsory joke about the Pandas library. I have no idea why they call it Pandas actually, but yeah. So the Pandas is a library that is used to handle tabular data, right? Which is basically an Excel sheet. In Pandas, this table format is called a data frame. So instead of calling it an Excel sheet, they call it a data frame. But almost everything else is quite similar to what you already know. So you have a row, which is the horizontal one. So row 1, row 2, and more rows. And then you also have columns, column 1, column 2, until column n, right? And the columns usually represent the variables. So for example, the head, the title of the first column could be age, for example. Then the entries in that column would be maybe 10, 12, 36, I don't know. Yeah, so basically they correspond to ages. Yeah, so this is how data is expected to be in when you are using a Pandas library. Okay, the next step will require me to stop the sharing. Okay, so have y'all used Jupyter Notebook before? Someone just, could I get a sense in the room? Jupyter Notebooks. Okay, so for those who somehow have Jupyter Notebooks in their computer, you can actually use Jupyter Notebooks. If not, you can go to this link. Oh, sorry. Okay, which I'm sending in the chat. All right. Yeah, so it's called Google Colab. So Google Colab, I think it should look something like this for your. Yeah, so it's basically, you can think of it as a Jupyter notebook, basically a Python notebook file, but hosted online by Google. Yeah, so you can open that link. Of course, you need to sign in with a Google email account. And then to get started, you can use this new notebook option. Then it'll go and create a new notebook for you. Yes, you can name it whatever you want. So the good thing about Google Colab is that your file is automatically saved into your Google Drive. So it won't take up any space on your computer, and you don't need to install any stuff or whatever. Oh, and alternatively, you can even use Visual Studio Code, which is local in your computer. So you don't have to use Jupyter Notebook if you don't have it. Yeah, Visual Code can also support Jupyter Notebooks. All right, but anyways. So yeah, so this is Jupyter Notebook, and all right, I'm gonna start typing some Python code here. So as we mentioned, we're gonna use the Pandas library, right? So to get the Pandas library running, you can import Pandas to bring it into your notebook, and yeah, and just run it. So to run, you can either click this button here, run cell, or you can press Shift Enter, and it'll run. Okay, so the SPD here is basically to define a shortcut so that you don't need to type Pandas all the time. And in the future, you can just type pd dot whatever to stand for Pandas. So that's the purpose. And all right, some other libraries that might be useful is NumPy, as mentioned before, and matplotlib. SPLT. Yeah. So Pandas here is to deal with tabular data. NumPy is to deal with math and array. Yeah, deal with math. And matplotlib, as the name suggests, is to plot. Right. Okay. So this is the setup, and I would also like you all to jump to this link. So in this link, we already hosted a data set. Oh, okay, that looks quite ugly. Yeah, but in this link, in this Google Drive link, there's a bank.csv, I think that's the file name. Yes, there's a bank.csv and a readme. So yeah, you can go and download these. If you're in Jupyter Notebook, then you can load the file into your notebooks. If you're on Google Colab, you can, so in the Google Colab, there's this folder button here, and then you can just upload your bank.csv file into this folder. How you upload is you can drag and drop, or you can click this button here to upload to the Google Drive, to the Google Colab. Any questions so far, by the way? No? Yes? Hello?
Sorry, how do you upload a file for like using Jupyter Notebook?
Using Jupyter Notebook, okay, I have to tell you that I don't quite use Jupyter Notebooks. So I think as long as they're in the same directory, they should be okay, right? I think there's you would launch Jupyter Notebook from a specific directory. So if they're in the same directory, then then it's fine.
Okay.
Yeah. If you want to,
oh, sorry. Was I interrupting something?
No, you were not.
Oh, okay. Yeah. So I actually have the Visual Studio Code.
Oh, okay.
How do I run a notebook on it?
Oh, I think you need to install an extension. So there's this button here.
Yeah.
Yeah, I think if you search for notebook, there is yes, there's a Jupyter Notebook.
Jupyter, okay.
Yeah, it's a Jupyter extension.
Yeah.
Then you can open it like it's Jupyter Notebook. Yeah.
Okay, then I have to name it the .pynb, right?
Yes, IPYNB.
IPynb. Okay.
Correct. Yes. So if you're using Python, then it will be a .py extension. But in notebooks, it becomes IPYNB. Correct. And who was asking about the Jupyter Notebook question?
Me.
Okay. So if you want to verify if your notebook can find it, right, you can try to run this command here. As the name suggests, read CSV. It's attempting to read the CSV. So if it works, then you should see something like this.
Okay, I'll try that.
All right. Yeah, so basically all the commands that I think I'm going to use my Visual Studio Code because I'm more familiar with it, but the rest of the commands will be exactly the same regardless of whether you use Visual Studio Code, Jupyter Notebook, or Google Colab. So don't be worried. Yeah, just remember for Colab users to upload your bank.csv file first. Otherwise, it won't run. Okay. And maybe while waiting for people, y'all can listen to me narrate the story about this problem. Yeah, so this is the sort of the storyline of why we are doing this. So yeah, suppose there's an insurance company S that is trying to promote their insurance plan. And they do this by somehow shadily get information about people, and then they're gonna just cold call the people in their list. And at the end of the call, the person that they called may choose to sign up with the company or not to sign up with the company, right? And because this company is a cheapskate, whatever this company is, they want to minimize the number of calls because yeah, they don't want to pay so much to call people. Even better would be if they can figure out whether someone is likely to sign up or not before calling. So that's the objective here. And they approach you to solve this problem. And to answer this question, you request data from the company, but the company decides to give you the whole thing, so that bank.csv that you have, yeah, they are tossing you their entire data bank, and then they ask you to do everything yourself. So yeah, so that means that a lot of the things that are in the data bank may not be explained properly now. I mean, they do try, they give an explanatory note, which is also attached in the README there, but some other things you may need to sort of figure out yourself. So the question is, what variables do you think you should use to predict whether a person will sign up with a company or not? Right. The variables that you can consider are here. There are 20 of them actually, because the company decide to throw everything to you. So if you open the data, right, if you do this read CSV thing, you see so this is the data frame, and then you see the column names are these things, right? Age, job, marital, education, and so on. So the meaning of these things are written in the README. So age just means age of the customer, job of the customer, marital status, and so on and so forth, right? So yeah, so there's a lot of data in there. And then lastly, in the last column is this thing called Y. So Y corresponds to whether the customer as described. So the customer as given here, in the end, did they sign up with a company or not? So in row 1, so one row represents one customer, and customer number 1 did not sign up. Customer number 2 did not sign up, 3 did not sign up, and so on. Yeah, so this is sort of how you interpret this table, this data frame. And remember that your job is to figure out which of these 20 variables do you think will be useful to predict if a given person will sign up or not, right? So you need to, as a requirement for this problem, you want to sort of think of, so you pick a variables first, and then think of why do you think these variables will be useful, and then use the libraries and your Jupyter notebook to either prove your case or argue against your case. Does that make sense? So if, let's say, I argue that age is very useful, and then because maybe people of age 30 don't think that they need an insurance plan, but people of age 59 is probably more likely to get insurance. So that's a hypothesis that I have. Now your job would be to use Jupyter, your notebook, using Pandas, Matplotlib, and NumPy to check whether your instinct was correct or not. Yeah, so that's the generic task here. I'll give some time to digest, I guess. By the way, if you all have any questions, feel free to just shout out. Yeah.
Hello.
Hi.
So now I'm using Google Colab, right? How do I know if the file, the bank file is already uploaded or not?
Oh, okay. So it should appear here. If it doesn't, you can press this button, refresh, and then hopefully it appears.
Refresh.
Yeah. Okay. Let's see if I can. Does it work for you?
It said here could not fetch bank.csv from backend.
What? I've not seen the error. You can try uploading again, I guess. Yeah, so the bad thing about Colab is that because it's a free service, right? So Google tends to be some issues with it, especially if there's a lot of users.
Oh.
Yeah, but in general it should be okay. So here I am trying to upload one. So yeah, so there's this loading bar here. Yeah, so it appears there. Then it appears here. If you press this button, for example, crap. You use the document. Open. Yeah, then it'll attempt to upload.
Do you know where I should put the file in for the Jupyter notebook?
You can put it anywhere you want. As long as this command runs, it's fine. The concern
Because
is if this
I
command
get an
doesn't.
error, it just say no such file or directory, then okay.
All right. Jupyter Notebook, is it?
Yeah.
I'm going to need to find. Oh, do you know where you launch? Which directory do you launch your notebook from?
Which directory? Just the C drive.
C drive, is it?
Yeah.
Okay, so you might need to put your notebook directly at the C drive. Sorry, your bank.csv directly at the C drive.
Do I still name it CSV?
Yes. So still call it a bank.csv. Just for standardization. Alternatively, if you've got any issue, just use collab. Oh, by the way, you can also double click a CSV file, and then I think your computer should open it using Excel. But there's a reason why we are not doing that, which I can demonstrate. There you go. Okay, yeah. So if you open your CSV file in your Excel, right? Sometimes it looks correct like this in this case. So it actually looks like a table. But there are other CSVs where it doesn't quite work. Let me see if I can. Yeah, so if you look at this CSV, right? So I have two different CSVs here. The one we'll be using today is the bank.csv. So it's the one on the left. The one on the right here is a different CSV file from somewhere else. We will not use them, but it's just for demonstration purposes. So if you look at it, right, you see this column here. It says day of the week, but the information below it is most definitely not day of the week. There's no way you get a 61.5 day in a week. Yeah, so this is why we don't use Excel, because it tends to mess up things. It's actually the column names are all shifted. That's why this is a problem. If you scroll to all the way to the right, you realize that it's actually shifted a bit. Okay, I'm gonna continue. I hope not. I will not lose too many people. Yeah. All right. So I'm gonna attempt to continue. So yeah. So we can use pandas to read the CSV in using this function called read CSV. So basically, you can call a read CSV function, and you read the file that you want it to read. If your bank.csv is in the same folder as wherever you launch your Jupyter Notebook, then you are perfectly fine. This will run normally. The only problem is that if you only call this, right, if you only do this read CSV, you end up with this strange data frame with only one column, where clearly that is not how the data is supposed to look. So the reason why is because this particular CSV has been made with a semicolon as a separator. So that just means that to differentiate between column 1, column 2, column 3, the CSV decides to use a semicolon to do this. And that is why to make this work correctly, you need to tell it that the separator used is a semicolon. Then when you run this, you should get it correct. It should look correctly. Something like this. And that brings us to the first point. Don't assume that your data set looks nice. Most of the time it doesn't look nice. We're gonna come back to this point in a different workshop, but yeah, there's a need to check whether things are correct or not. And then the column names are given, so there's age, job, marital status, and stuff. And pandas have this function called describe, where basically so df is data frame, right? If you describe the data frame, pandas will show you relevant information about your data frame. So for example, it tells you that there are 4,521 rows here, and it corresponds to this number here. And then it'll auto calculate for you what are the average value, what is the average age, what is the standard deviation of the age, what is the minimum age in the data set, maximum age, and so on and so forth. Yeah. So as you can see, there are way less information in this describe table than the original data frame, right? So original data frame has a lot of columns, a lot of variables, but in the describe version, once you describe it, you only end up with 1, 2, 3, 4, 5, 6, 7. You only end up with 7 columns. This is because describe can only describe values that are numerical. So if you look at your README, the variables are actually annotated with numeric or categorical. Numeric means that its values are numbers. Like for example, an age. Your age is a number. Categorical means that it's categories. So for example, male, female, yes, no, or even a job, right? So unemployed, services, management, these are each individual category. So describe won't work for categorical data. It'll only work for numerical data, which is why after you call describe, it sort of forgets everything about the categorical data. Okay. And some relevant information, some important functions you can call to in pandas is this thing called ilog. So basically, it's log here stands for locate. So you're trying to locate data using the index. So here, what I'm trying to do is locate the data in row 3. But remember that in programming in general, rows start from 0. So row 3 actually means 0, 1, 2, 3. So it's the 4th row, despite the index being 3. And yeah, so here you see age is 30, job is management and stuff, which corresponds to this row, 30, management, married and stuff. So this is how you can access individual data points in your data set, in your pandas data frame. You can even access multiple rows immediately at the same time. So in this case, I'm trying to access row 1, row 10, row 4, and row 3. So how do I do that? If I only want to access a particular row, I'll put, let's say, row 130. But if I want to do more than one row, then I'll have to enclose it with another pair of square brackets. Then I can put whatever number I want. Do this. Oh man, okay, I need to run again. Oh, and in Jupyter Notebook, things are connected. So, for example, df was called here, was defined here, right? But when you run this thing, it'll actually remember that df was run there. So you have to run the cells sequentially. Yeah, and then if you call ilog 1, 2, 3, 4, it'll access row 1, row 2, row 3, row 4. Right. Okay. Yeah, so these are, at this point in time, I'm just introducing some of the basic functions in pandas. And another thing that is probably useful is to access your rows using conditions. So for example, here in this row, in this line, what I'm trying to do is I'm trying to get all rows whose job column says services. So get all the rows in DF where the job column df job is equal to services. And if I do that and I try to display what it says, yeah, so you see the column under job, they are all services. And I can even do this with other columns, right? Like for example, in the second line, what I'm trying to do is to get the rows such that the marital column says Mary. So if I call that, then it'll show Mary. They're all married. A bit more advanced is to actually combine conditions together. So I don't know what to call it. Let's call it X. So I can take all the rows where the job says services and the marital column must say Mary. Oh, sorry. Need to put brackets here. Yeah, so ampersand here just means and. That means the job column says service and the marital column says Mary. Yeah, so here you see that both columns now show whatever you want it to show. This is service as married. Okay so far? Right. Yeah, I think these are very basic functions in Pandas lah. I'm not gonna show the whole all the things that you can do in Pandas because the Pandas library is big. These are the most as basic as it can get. I think the slides actually contain slightly more information about Pandas. So yeah, there are a bit more stuff in the slides. You can how to remove columns, for example. So you can use the drop command to remove columns. Yeah, and you can even apply functions. So you can make if you have an error column, right, and then you want to make this new data called error squared, you can call it in something like this. Yeah. But honestly, these things are Googleable lah. So Google is your best friend. You can search them up online to see how to do certain things. Alright, so that's for Pandas. The next thing is NumPy. So NumPy, it's a library for Python that helps you to do mathematical operations. So for example, operations like taking averages, calculating standard deviations. You can technically write your own code to do this but NumPy allows you to not write any complicated math code. So this is one way of using it. So here what I'm doing is I'm only looking at the balance at the column that says balance. So I'm only getting this column for 789 minus 88 and so on, and I'm turning it into an array, into basically a list of numbers. So if I print out what balance looks like, if I print this out, yeah, it'll just be a list of numbers like this, because well the column balance is just a list of numbers, right? Then once you have this list of numbers, you can use NumPy to np.mean, so NumPy mean to calculate the mean of balance, then standard deviation of balance. This is how you can do that. And again, there are other functions in NumPy which due to time constraints will not be covered also. Yeah, they are also Googleable. So again, Googling is the best one.
Excuse me.
Mm-hmm.
Yeah, sorry to interrupt, but I was wondering if there was any good way to do this. Yeah, let me paste it in the chat. Like, I want to find out, like, how many people was a success and how many were failures. And I want to do it
Okay.
so that it shows in like a nice table, right? So is there any nice way to do this rather than, copy paste it 4 times?
In a nice table. Okay, so I'm pretty sure there's a pandas method that you can, there's a pandas function that you can use to do this, because it's basically a more specific version of describe, right? Like you describe as one particular condition, yeah. But leave that up to you to search. Yes. Okay. Yeah, so remember that the goal of this whole exercise is not to actually fully learn and use pandas and NumPy. Remember the task was to figure out which variables, right? So this is probably a good time for you to think of which variables to use and then try to come up with ideas on how to verify these, verify your hypothesis, whether these variables are actually helpful or not in predicting. So think of your whatever statistical or mathematical techniques that you can come up with to help you in this task. Yeah. Okay. Lastly is matplotlib. So matplotlib is, as the name suggests, to plot data, right? So here I'm trying to plot this balanced data. Yeah, so matplotlib has this convenience function, has this function called plot, which will plot whatever thing that you pass to it. The problem is that sometimes it's not very helpful. Like, for example, if I just plot balance like this, right? Oh, by the way, balance, what does balance mean? It's here. Oh, it's not here. Oops. Okay. Yeah, but anyways, this particular way of plotting information is not useful because there's hardly any information you can derive from this. I guess the only thing you can tell is that there's one peak that goes up to 70,000, but that's probably all. So there are other ways of plotting data that might be helpful. You can consider scatter plot, for example, but actually, if you look at scatter plot, it's also not that helpful, right? I guess now you get a bit more variation. You can tell that most of the data actually lies between 0 to 10,000, with occasional anomalies beyond 10,000. Yeah. And there are other forms also. You can even form histogram. So when you plot the balanced data using histogram, you realize that majority is literally in 0, like around 0. And by majority, we mean 4,000 of the data points are in 0. And if you recall, the total number of rows we have was 4,600. So it's way more than 50%. Yeah. So you can plot the same data in different ways together to gain different information out of it. The takeaways will be different depending on how you plot these data. Right. The next part of the exercise. So this has been a brief introduction to pandas, NumPy, and matplotlib. The next part of the exercise is to basically give everyone time to work with the exercise. So yeah, come up with a with your variables, your reasons, and try to sort of use what we have use pandas, NumPy, and matplotlib to gather evidence regarding your hypothesis. In order to show your train of thought, right, there's this thing called markdown. So in VS Code, it will be this button here, markdown. In Jupyter Notebook, there's a button somewhere that would say this thing called text. So in Colab, it's called text. Yeah, so you can basically type whatever you want here. It's not code. It's like a comment for you to remember what you have done. So you can use this to sort of document out what were the variables that you were considering. Why do you consider them? So as an example, I would put age because people of higher age may feel more at risk, hence more likely to take up insurance. Yeah, so you can use this markdown to document out your train of thought. This way, once you send your notebook to someone, they know what you're doing. They know what's happening behind the scene. Yeah. So the next step will just be for the next maybe 5 to 10 minutes. Yeah, I'm gonna let everyone to just play around with stuff. Oh, Andrew, did you manage to solve your bank.csv problem?
I just went to Google Colab.
I see. Okay. And it works in the end?
Yeah, it works.
Oh, okay, nice.
Actually, I just have a question. Is there like a function that you can use on Pandas? Because I'm relatively new to the Pandas interface as well. So like, wondering if there's a function which can count the number of times in which a particular column or row returns us a value. So for instance, like, yeah. So for instance, like you see here, I mean, if I could share my screen.
Yeah. I think you asked the same question as Kelvin, is it?
Oh, was it? Oh, but he asked on the chat.
Yeah, he sent it in the chat. Yes.
Yeah, so I just like, they put all the no here, then I just want to like sum it up.
Yes. So one manual way you can do it is as written there in the chat. So it counts the number of entries of P outcome that says success.
Oh, see.
Yeah. But that's manual because if P outcome has let's say 10 possible entries, right? Then you're gonna have to do that 10 times. So yes. You can solve it by figuring out the pandas function to do this, or you can program a loop such that it loops over all 10 possible entries.
I see. Yeah. Because you have to do this for every separate. Yeah. Thanks.
Yep.
Hello?
Hello?
Yeah, sorry. I still don't manage to upload the file somehow. Like, I can see the file on Google Colab, but it just cannot read. I'm not sure why.
Oh, what? Okay. You wanna share screen?
Okay. I can see the file here.
This directory structure looks strange. Let's see. I think, can you scroll? I think you need to go to home.
Go to what?
Home. The folder. Wait, let me check. Let me check something. Sorry.
Okay.
Yeah. So basically, you're in a. Okay, if I. Content. Yes. Okay. So there should be a folder called content.
Okay.
All right. So your file needs to be in that folder.
inside the content folder.
Yes, so you want to move it to the content folder. Yeah,
Okay.
a bit troublesome, but I mean, you can always upload again. That's an option.
Okay. Okay, yeah. Thank you.
I get some p days value as -1. What does that mean?
Sorry, who's speaking?
Some of the p days
Oh.
value I get is -1.
Yes. So remember how we talked about missing data?
Okay.
Yes. So occasionally, if you look at the table, right, there are some entries that says unknown, and some entries that say -1. Yeah. So these are basically some of the different ways that people use to encode missing information.
I see.
Yeah.
Okay.
So it'll be up to you as to how you want to interpret this. Do you want to consider it, or do you want to ignore them?
Okay, got it.
Yep. Right. I'm gonna excuse myself for a few minutes. Sorry. I'll tell you when I'm back. Yeah, so this was the task that I was saying. If you're somehow very fast and you are done with like 3 variables, identifying your 3 variables, you can explore these other things. So we said that matplotlib is a library to plot stuff, right? There's actually another library you can use called Seaborn. It actually looks nicer. I personally like Seaborn more. Yeah, so that's one way one thing you can try out also. Then the other thing you can try is also to combine different features together. So maybe you figure out a way to sort of combine different informations in this table together to get something that is more meaningful, right? So if you can do that, feel free to do so. Yeah, and lastly, also don't just argue for your case. Try to argue against your case. Figure out like maybe there are certain steps that you took that were quite shady or were quite maybe you took certain assumptions that doesn't generally hold, right? So if you can figure this out, it'll be good to just write it down in your text, in the markdown just now to sort of document out the strengths and weaknesses of your approach.
Can I just use Seaborn and not matplotlib?
Sure. I mean, if you have experience with Seaborn, you can use Seaborn.
Hello.
Hello.
Sorry, I'm still a bit lost. It's like,
okay.
so what we should import our pandas, NumPy, and matplotlib.pyplot, right?
Correct.
Okay, and then what's the df then? Because I don't think import anything as df, right?
Correct, yes. So here you are basically reading this information from the file, and then you are saving it into df.
Oh.
Yes, so that you can subsequently just call df and not read the file again.
Oh, okay. Yeah, thank you.
Okay, in about maybe 2-3 minutes time, I'm gonna get someone to share their variables and basically what they've done. So yeah, just give it a shot, I guess.
Alright, could you briefly go through matplotlib again? I think I didn't catch that part.
Alright, so so there are a few functions that to keep in mind. The first one is this function called plot. Okay, it's basically just plotting this kind of it's not kind of like a line. Yeah, it basically just connect all the points that is present in your data. So the data that we pass it in was balance, right? Which is balance is a list of numbers. Yeah. So how does it generate this 2D graph, right? If you only pass in one list of numbers, whatever thing you pass in will become the y-axis, and then the x-axis will basically be the order in the list. So the first element will be a point here, and then the second element, third element, fourth element, and then it'll just draw a line over all the points. Does that make sense? So if I show you only like the first 10 points, right? So 0 to 9. Yeah, it looks something like this. So it just joins up all the points with a line. So that's what the plot function does. And then the next thing is the scatter plot. So scatter plot, yeah, it won't draw any lines to connect. It'll just put a point there and then move on to the next point and so forth. Because it's a point, you need to pass in both x and y axis. Yeah, the x coordinate and y coordinate. So here, this thing here is basically the list of x coordinates, and then valence is the list of y coordinates. That's why if you compare to just valence alone, they look pretty similar. The only difference is that in the first case, you are connecting lines together over the points. In the second case, you're only showing the points. There are no line connection happening. So this is scatter plot. And then lastly is the histogram, where basically it'll auto do everything for you lah. So you get a list of numbers, and then it'll do the binning to get it'll group it into 10 categories in a way that Matplotlib thinks is useful, and then it'll just draw. So these are, like, if you see here, these are the bins lah. Like how many categories does it divide your data into?
Could you maybe share this file so that we can refer to it?
Yeah, sure. Okay, this was my attempt to just play around with things. I can share it, I guess. I'll just upload into that folder where I put the dataset. Is that okay?
Yeah, thanks.
All right. Alright, uploaded. Yeah, it's called play because it was literally to play around with the functions. Alright. I think I'll get one or two people to sort of share what they've done. Any volunteers? Volunteers. There's 33 people in the call. So. No? Hey, come on there. Alright. Gotta randomly pick someone then, I guess. Let's see. Wait, legit no volunteers? Let's not summon the random number generator so early. All right. Wait, shit, that's me. Oh wait, no. Homer who? Are you there? Wait, that's not your real name, right?
Yeah, it's not. I'm using my high school account, and well, I'm sorry that because I cannot open the Jupyter Notebook and the Google Drive because I'm currently in China and my computer hasn't installed the VPN, so I'm just listening to you guys and not actually done anything. So
I see. Okay, no issue. But okay, a quick question then. Or do you you saw the list of variables, right?
I can saw them when you're sharing your screen. So
all right, let me just share it again.
Okay.
Okay, these are the list of variables. Okay, I'll just put them side by side. All right, so these are the list of variables here.
Okay.
Age, job, marital, education. So what do you think is a good variable to use to predict whether someone?
So to predict the the length of the core, right? I guess that's the original task.
Mm-hmm.
Okay. So, well, I believe perhaps, so I'm going to list out 3 variables, right?
Yeah. And
okay, so
just
then
justify your answer.
Yeah, so maybe contact. That's the most trivial one, I suppose.
Okay.
And also I believe they're kind of income. I'm looking for if there's something that's related to income or something like. So.
Okay.
Oh wait. So perhaps day of week is also something that might determine. And also the duration. But because basically, yeah, I was thinking about something like income, but then I think maybe just something more directly related to the information about something about their contacts would be more important. So yeah.
I see. All right. Okay, that's fair. I think that's quite fair. All right, we'll get to that point a bit later.
Okay.
Okay, I'll show you what I have. Yeah, so this is my solution-ish to this problem. Yeah, so as I mentioned, I personally would think that age is something that matters because the older you are, the more likely you are to fall sick. So if you have an insurance plan, that's probably good for you. Young people tend to not really think that they're gonna fall sick, so it's quite unlikely for them to take up insurance. That's my personal belief on this matter. And the other thing that I was thinking was about loan. So people with loans may feel more at risk because yeah, I mean they already have loans that they need to pay up lah. And so they might be more likely to sign up for insurance, right? So this is what I had in mind. And in order to verify whether this is true or not, I'm going to do some stuff. Yeah, so you've seen this before. This is to load up the data and stuff. And because I really only want to look at age, right? So I'm going to remove everything and only take the age information. So now this variable age will contain only a list of age in the data set, right? And then the outcome is in the Y column, so I'm going to take that column and then list of outcomes. Yeah, and then next is I'm going to use the scatter function to plot the relationship between age and outcome. But the thing is, if you use the scatter function on these two variables, right, you'll get this strange looking graph that doesn't quite tell you what you want, right? I mean, it's very hard to interpret this graph lah. Like it's not telling you any information. Yeah, so that's another lesson, which is not to just plot stuff. Try to find a way to meaningfully show what you're trying to do lah. Yeah, so that you can't actually use the scatter plot to visualize because it wouldn't give you much useful information. So what I had in mind was to show the distribution. So basically I'll plot the histogram for age, which looks something like this, and then calculate the average age and the average standard deviation. Right. So the average age seems to be 41. That means that it seems like the people that they are calling or have called in the past is typically aged around 41. And this is the distribution of the age data as according to the histogram function. Okay, so why are we looking at distribution of age, right? The reasoning is that if age and the outcome yes is correlated, right? That means people of a certain age is more likely to get to say yes. Then when I plot the age of people who say yes, I should get something very different from the average people, if that makes sense. So if younger people are more likely to say yes, then the average age for the people who said yes should be less than the average age because the younger people are more likely. And vice versa if it's the older people. Right, so that's the approach that I had in mind when I was doing this, which is why we are looking at the average case first. So the average person is apparently 41 years old. And then if we condition on yes, so we only consider the people who said yes. So which is what we are doing here. So remember how in Pandas you can set conditions. So we are only going to take the data. So take the data whose y column is yes. So this is what I'm doing in the first step. And then in the second step, amongst all who said yes, get their age. Right, yeah, so this is what's going on here. So this is the condition, outcome must be yes, and then put the information in this variable, and then get all the age of these people. And once I do that, and I calculate the mean and average again, you realize that the averages are now different now. Now it's 42.49. Recall that it was 41.17 just now. So the average goes up. So among the people who said yes, they are actually more likely to be older, which is in line with our starting hypothesis, which is that older people are more likely to say yes. So in line with hypothesis that older people will say yes. So this is the idea of the analysis, and repeating the exact same procedure, but amongst the people who said no. So amongst the people who said no, getting their age and then calculating their averages. Well, it looks like there's a similar pattern. In fact, now it decreases to 40.99. So again, it's in line with hypothesis that younger people will say no. Yeah, so this is how you can sort of use visualizations in either plotting information or calculating mean and averages and standard deviations to convince yourself that your hypothesis was correct, right? And the question is, do you think that this difference in the averages, do you think that they are significant or not? Because if you consider the difference, right, in the average, it's actually very, very small. The average case was 41 years old. For the ones who said no, it was 40.998. And for the ones who said yes, it was 42.4. So do you think that this average is significant enough such that your hypothesis is validated? Or do you think it's not significant? I mean, that's a different question now. So it's a criticism of this approach. But yeah, just to be balanced. So this is how you can use all these things that we have shown you to help validate or counter your hypothesis. And the other variable that I considered was loan, right? And for the loan data, very simple, because loan is basically either yes or no. So yes means yes, you have a loan currently in place, and no means you don't have. So for this one, I'm just going to see the ones whose loan was yes and who really end up signing up, and see the ones whose loans was yes and didn't sign up, the ones who didn't take a loan but sign up for the insurance, and the ones who didn't take up a loan and didn't sign up for insurance. So 4 possible cases. Right. Okay, the variable names here are definitely can be improved. This is meant to be a proof of concept of sorts. All right. So the reason why or rather I consider this approach was that if there is a correlation between loan and outcome, right, outcome of whether they will take up the insurance or not, then I will be able to see some difference. So for example, if those who take up those who take up loans are more likely to take up insurance, then yes should be more than yes no. But if it's the other way around, then I would probably look at no yes versus no no and consider their values. So that was the idea behind this approach. So I can print them out. I can just use a print statement in Python to see the different values, or I can use matplotlib to plot this table here. Yeah, so this is something called, you can call it a correlation matrix, or basically it's a matrix, and it's color coded so that you know exactly what you don't need to know the specific number, but you can at least tell if one thing is bigger than the other. So yellow here means it's more than 3,000, and what is this? This darker purple is down here so very little. So how do you interpret this diagram? This diagram is most definitely not the best diagram that can be plotted, evidently, since it doesn't seem like it conveys a lot. But the interpretation is that because the thing that we are trying to plot is this table, right? So yes corresponds to this corner, no yes correspond to this corner, yes no correspond to this corner, and no no correspond to this corner. Yeah, so the definition of what each of these variables mean are here. So no no means they didn't take up any loan and also end up not signing up. So this is a particular method of visualization that I've picked. Now the question is whether this visualization is helpful or not in proving my case, right? Because if you look at the number of no, it's like way more than the number of yes, right? In fact, yes is 43, but no is if you just get the number, you get some super large number, 3,000, yeah, which correlates with the color. Yellow is way more than 3,000, right? So does it mean that the no people are more likely to say no? So the people who never take up loans are more likely to not sign up for your insurance. Is that the conclusion that you can draw from this? So that's a separate question again. It's a question of how would you interpret this information that you've gotten. Yeah, but that's sort of the idea here. So we come up with a hypothesis and then we play around with the data, figure out like how should you, what information do you think you can get such that you can either support your case or argue against your case. Yeah, these are very simple ways in which you can do that. In next week's workshop, we'll go a bit more into the modeling side, so into linear regression, and then we'll also see how this linear regression can be used to support or counter your hypothesis. Yeah, and that more or less wraps up the workshop. Any questions? I assume there will be a lot of questions.
Actually, I just have a question on, do you have any advice you can give us as to like what workshops that we can do to best accelerate our learning for Matplotlib and Pandas? Like I know my seniors talk about like using Kaggle and stuff like that, but I was wondering whether there's a better way, because I think Kaggle is quite quite like beginner, like really beginner. I'm not an expert, or I'm not even intermediate. I'm also a beginner, but I think like the Kaggle is like quite,
yeah. All right. I am probably a bit biased on this, but I'm of the belief that these things are tools, right? So you should not learn them for the sake of learning them. I would personally wait until there's a problem that you need to solve. Like when you're working in a project for FinTech Society, then you realize you need to use Pandas, right? Then that's probably a good time for you to like Google up the things like let's say if you have a specific thing in mind that you want to do already, then you go and Google how to do that thing. Does that make sense?
Yeah, so it's like hands-on. So
yes.
So you just recommend like maybe we just read up on the basics, that's all, and know
Correct,
that
yes.
something is there.
Correct,
and
yes.
we just like do the projects and learn from it.
Yes.
Okay.
Which is why if you realize workshop 1, I don't think I taught a lot about Matplotlib, NumPy, and Pandas. And that's the reason behind it.
It's just like showing us like a brief overview of like features and stuff, so that we know it exists.
Correct, yes. It's more of if you face this particular problem set, how should you sort of, or how would you look at it, and then how can you use these libraries to help you in your case.
Okay. Yeah. Thanks.
Yep. Yeah, quick disclaimer, these 2 variables are not the best variables, and in fact the visualization for one of them is not even useful. Yeah, the visualization for one of them is not even useful. The point to take away is it's the process in how you address this problem, which is that you have a problem, you come up with a hypothesis, try your best to either counter or support your hypothesis, and then work from there. That's the purpose of this introduction. Right. Any other questions? By the way, if not, y'all can feel free to leave. I'm gonna end the meeting, the recording.
Okay, thank you.